How do you do, boys and girls? Welcome to the digital classes. Today we are going to discuss speed. I want you all to repeat with me. Speed. Yes. In the earlier class we have learnt what is motion, rest, distance, displacement, speed. Today we will discuss speed a little more in detail. Let us revise what we have learnt in the earlier class. We discussed up and down are relative, left and right are relative, motion and rest are relative. Motion is defined as an object is said to be in motion if its position changes with respect to an observer and time, and rest is defined as an object is said to be in the state of rest if its position does not change with respect to an observer and time. Speed is given by the formula distance covered by time taken. The units of speed are meter per second and kilometer per hour. Let us discuss speed a little more in detail. In this class we are going to discuss average speed, instantaneous speed, average velocity and instantaneous velocity. Now students, I want you to imagine the greatest speed with which you have travelled in your life. Quickly imagine those situations where you have travelled with the greatest speed. Concept of speed plays a very important role in our life. For example, a farmer who has to reach his farmland at morning 6 o'clock sharp, he has to decide when to start. It depends on how far is the farmland from his house. Also, the mode of transport he selects. In other situations where, let us say, a child has to write an examination in a school which is 10 kilometers away and he has to write at morning 9 o'clock. The child has to decide when he has to start from his house. Or a family has to attend a wedding in other city which is 200 kilometers away and they have to reach tomorrow morning 11 o'clock. So when the family should start to reach the place in time. Or in other situation where we get holidays, let us say 3 days in a row, and we would like to go on for a tour and we have to decide which place we have to travel and whether we can visit the place and come back in time and comfortably, which is also more important. So to answer all these questions, we have to have a clear understanding of speed, time and distance. Now consider the following examples. When we walk slowly, speed is around 1 meter every second. This comes out to be nearly 3.5 kilometers every hour. Athletes sprint 100 meters in about 10 seconds. That's Usain Bolt, who sprinted 100 meters in 9.58 seconds, which is 37.57 kilometers per hour. But we can run only short distances at this speed. We can reach a speed of over 100 kilometers per hour on a cycle, but the average speed over long distance is about 25 kilometers per hour. An auto rickshaw travels with a speed of about 60 kilometers per hour. A bus travels with a speed of about 80 kilometers per hour. Two-wheelers can travel with a speed of over 100 kilometers per hour. Small cars can travel over 100 kilometers per hour. You can watch this in this video. Here a car is traveling at about 100 kilometers per hour. The trains in India can travel a little over 100 kilometers per hour. Here are some fastest trains in India. This is Vande Bharat Express, which can travel at a speed of over 120 kilometers per hour. There is another train, Shatabdi Express, which can also travel at over 120 kilometers per hour. Wind speed can be over 250 kilometers per hour during a cyclone. Passenger aeroplanes travel at over 1000 kilometers per hour. A rocket travels at over 11 kilometers per second to escape from the Earth's gravity. Elephants can reach a speed of over 25 kilometers per hour. The fastest snakes can slither at over 25 kilometers per hour. Here is a black mamba and a horned rattlesnake which can cross 25 km per hour. A cheetah reaches a speed of about 110 km per hour, but it has to be remembered that it can run only for about 30 seconds. Children, now consider a situation where a dog chases a cat. You all may have seen a dog chasing cat. Now let us learn some physics in this example. Here is a dog that can run at a speed of 36 km per hour, and this is going to chase a cat which can run at 12 meters per second. Now children, will cat escape from dog? Let's see. The dog travels at 36 km per hour and cat runs at 12 meters per second. Now both the units are different. In order to check which one is running faster, we have to have both the speeds in the same units. The dog which is running at 36 km per hour, we have to convert kilometer per hour to meters per second. So 1 kilometer is 1000 meters and 1 hour has 3600 seconds. So which comes out to be 36 multiplied by 5 by 18, which gives us 10 meters per second. So the speed of the dog, which is 36 km per hour, is equal to 10 meters per second. Now it is easy for us to compare both the speeds. So here clearly cat runs at a greater speed. So the cat escapes. Children, let us convert the speeds of some quantities from kilometer per hour to meters per second, and I want you people to do faster than me. Let's do. 54 km per hour will be 5 by 18 has to be multiplied with 54, so that you get 15 meters per second. 72 km per hour can be converted into meters per second by multiplying by 5 by 18, which gives you 20 meters per second. 144 km per hour when multiplied by 5 by 18 gives you 40 meters per second. So the speed of 144 km per hour is equal to 40 meters per second. Now children, let us solve some numericals. Here is a bus which moves from Hyderabad to Mahbubnagar in 2 hours, covering 100 kilometers. Find the speed of the bus. Speed is equal to distance covered by time taken. Substituting the values, the distance is 100 kilometers and the time taken is 2 hours, which gives us 50 km per hour. Speed is equal to 50 km per hour. The speed so calculated is called the average speed. Here, when the bus started from Hyderabad to Mahbubnagar, it starts from rest and slowly gains the speed, and then it travels at a high speed on a main road and then maybe stopping at different stops. But overall in the journey, the bus has covered 100 kilometers taking 2 hours. So what we have calculated here is the average speed. The average speed is the total distance covered by total time taken. We have instantaneous speed, which is the speed at a particular point of time. Instantaneous speed is the speed at a point of time. The speedometers in the vehicles give the instantaneous speed. Observe this video where a person is driving a motorcycle, but it is suggested not to drive at such high speeds. Here is a motorcycle and you can look at the speed seen in the speedometer. It is a digital speedometer and the speed is increasing. Children, we have to remember that we should not travel at such high speeds. It is not at all advisable. This is done by a professional and hence we are not supposed to repeat such stunts. I only give this example so that we can understand that during the motion the speed changes. Now children, observe the video of this plane. This plane is ready to take off and it started from rest and slowly it is gaining speed with the help of the engines under the wings, and it has took off from the airport. Children, so what we have observed is the plane when started has started from rest, the speed is 0 and slowly gained speed with the help of its engines and went on to another city at a constant speed during its flight, and then just before landing its speed slowed down. So, the speed is not constant throughout the journey. So, what we consider is the total time taken and the total distance travelled. So, we calculate average speed by the formula total distance travelled by total time taken. Consider another example. Here, a car travels 80 km in 2 hours on a highway and 40 km in 3 hours on a village road. Find the average speed. The total distance covered is 80 km and 40 km, which is 120 kilometers. The total time taken is 2 hours and 3 hours, total 5 hours. The average speed is equal to total distance covered by total time taken. So, the total distance is 120 kilometers, total time is 5 hours. So, 120 kilometer by 5 hours gives us 24 kilometer per hour. So, the average speed of the car is 24 kilometer per hour in this 5 hours. Consider another example. A truck travels 200 kilometers in 5 hours and next 100 kilometers in 7 hours. Find the average speed. The total distance covered is equal to 200 kilometers and 100 kilometers, which is 300 kilometers. The total time taken is 5 hours plus 7 hours, which is 12 hours. The average speed is equal to total distance covered by total time taken, which is 300 by 12, which is equal to 25 kilometers per hour. Children, now observe the following pictures. Here is a tortoise and a hare. This reminds us about the old fable. These two animals remind us from the old fable. We have learnt that slow and steady wins the race. Also, consistency is necessary in our performance. Now, let us learn some physics from this story. The hare and the tortoise started for a race. The hare started swiftly and the hare sleeps for some time, whereas tortoise crawls slowly and consistently. Children, I would like to make a small change in this story. Let both hare and tortoise win the race. Both hare and tortoise finish the race at the same time. Though hare covers the entire distance quickly, it rests for some time, whereas tortoise crawls steadily till it finishes the race. Though their motions are completely different, their average speeds are same. In this story, the hare and the tortoise both have travelled at different speeds in the race, but both of them have taken the same time. Since they have covered the same distance and taken same time, their average speeds are same. Let us consider another example of nature, the survival of the fittest. Here is a cheetah which spots a deer which is 100 meters away from it. Even the deer realizes that. The deer starts running away and cheetah chases it. Look at the nature. Here the deer is running for its life, whereas cheetah is running for its lunch. The race is same. Here the race is same, but one animal is running for its lunch, the other animal is running for its life. So, coming back to the question, here we should find out how far the deer runs before the cheetah catches it. Here the hint is both of them have travelled for the same time. Let the deer ran for x meters and the total distance cheetah covered will be 100 meters plus x meters. Both cheetah and deer run for equal time, say t seconds. Deer runs at 20 meters per second for t seconds. So, the distance x is equal to 20 times t, which is equal to 20 t. Cheetah runs at 30 meters per second for t seconds. So, the distance is equal to 30 t, which must be equal to x plus 100. So, the distance travelled by cheetah is x plus 100, which has to be equal to 30t. Substituting, 30t is equal to 20t plus 100. Rearranging, we get 30t minus 20t equal to 100, which comes out to be 10t is equal to 100 and t equal to 10 seconds. So, the deer has travelled for 10 seconds before it was caught by cheetah. So, the distance will be 10 seconds into 20 meters per second, which comes out to be 200 meters. Consider another example. A bus travels at 60 km per hour for 2 hours. Find the distance covered in those 2 hours. So, the average speed is total distance covered by total time taken. Substituting the values, 60 km per hour is equal to distance covered by 2 hours. From this, distance is equal to 60 kilometers per hour into 2 hours, which is equal to 120 kilometers. Consider another example where the same bus travels. The same bus travels 300 kilometers at 60 km per hour. Calculate the time taken. Average speed is equal to total distance covered by total time taken. Substituting the values, 60 km per hour is equal to 300 kilometers by time. So, time is equal to 300 by 60, which is 5 hours. So, the bus has covered 300 kilometers in 5 hours. Children, let us consider another example where a pigeon and 2 trains are involved. Here are 2 trains which are 400 kilometers apart, and there is a pigeon on one train. Both these trains are on the same track. These trains, I name it train A and train B, both of them can travel at 50 km per hour. When both the trains start at the same time towards each other, the pigeon on the train A starts with a speed of 80 km per hour towards the train B. Traveling faster than train A, the pigeon is able to meet train B. The moment it touches it, quickly it returns to train A. It meets train A and then returns to train B and then returns to train A, and it keeps doing it till the trains meet. Children, now the question, what is the distance travelled by the pigeon before the trains meet? This appears to be impossible to calculate, but children, I tell you, physics is very simple, and if we use little bit of maths, we can solve all these numericals very easily. We have to divide this question into parts. So, the question is, 2 trains are going to meet which are 400 kilometers apart. Both trains move at the same speed, so both should travel same distance, that is 200 kilometer each. Each train travels at 50 km per hour, so the trains take 4 hours to travel 200 kilometers. Now, you know the time taken by the trains to meet. So, all these 4 hours, the pigeon was traveling at 80 km per hour. So, in these 4 hours, pigeon was traveling at 80 km per hour. So, it travels 4 times 80, which is 320 kilometers. So, the total distance covered by the pigeon is 320 kilometers. Children, from this example, I would like to tell you that sometimes the problems appear bigger and difficult to be solved, not only in physics or maths, but sometimes in life also. What we have to do is break down the problems into smaller parts and then try to find out or solve each part separately, and then we come to the solution. Just like average speed, we have another quantity which is average velocity. Average velocity is the total displacement covered in total time taken. Let us solve a question. Consider a rabbit which moves from A to B as shown in the figure in 10 seconds. Find the average speed. Here the distance is 5 meters plus 12 meters, which is 17 meters. So, the average speed is 17 meters divided by 10 seconds, which comes out to be 1.7 meters per second. Now, let us calculate the average velocity in the same case. Here the average speed is 1.7 meters per second. To find out the average velocity, we need to find out the displacement, which is 13 meters. To calculate the average velocity, use the formula total displacement covered by total time taken, which is 13 meters by 10 seconds, which comes out to be 1.3 meters per second. Average velocity is the total displacement covered by total time taken, and average speed is total distance covered by total time taken. Both have the same units, meter per second or kilometer per hour or miles per hour. Let us compare average speed and average velocity. Average speed is a scalar quantity, whereas average velocity is a vector quantity. Both have the same SI units. Children, let us solve another question. Here, a boy starts from his house to a shop which is 50 meters away. He returns immediately as the shop is closed, taking total of 25 seconds. Find the average speed and average velocity. To find the average speed, we need the total distance covered. The total distance is 50 meters towards the shop and another 50 meters while coming back to his home. He took total of 25 seconds. So, total distance covered is 50 plus 50, 100 meters. Time taken is 25 seconds. So, the average speed is 4 meters per second. Now, let us calculate the average velocity. Children, in this example, the boy has moved from his house to the shop. Because it is closed, quickly he returned, taking total of 25 seconds and covering total distance of 100 meters. But the average velocity, which is total displacement by total time, is something different. Because the boy has returned to his house, the starting and final points are same, so the velocity should be 0 because the displacement is 0. Children, in this example, the displacement, which is the distance from starting point to the final point, will be 0 because the boy has started from his house and reached his house at the end of the journey. As the starting and final points are same, the displacement is 0 and hence the average velocity has to be 0. In the last class, I asked a question, what is the velocity of a house in a day? We have to remember that house is situated on the earth, and as the earth rotates, the house also makes one full revolution coming back to its same point in one day. So, the average velocity has to be 0. Children, let us revise what we have done in this class. We have seen average speed is total distance covered by total time taken. Average speed is total distance covered by total time taken. Average velocity is the total displacement covered by total time taken. Children, we have learnt about speed, average velocity in this class. What I want you people to do is take out the physics textbook, work out the numericals and answer all the questions. Discuss these concepts with your friends, and if you have any doubts, get them clarified with your teachers. Let us meet in another class with more ideas of physics. Thank you.